Hello, my name is Justin Lovell. Welcome to ERP to Cloud Integration Redundancy Patterns, made possible by the fantastic Azure tools. Let's just jump straight into a session overview. It's going to be fast and furious. There is a total amount of content we're going to get through, so please bear with me. We're just going to do a little bit of an introduction to our journey, look at some project statistics, and then review some different patterns with regards to requirements, the design, error handling, transformations, and then how to manage our solutions going forward. Just a little bit about who we are. D-Mix, 6 of us, started 2018, do a lot of software dev, but we focused on integrations, ERP integrations, CRM systems to ERP systems, a lot of big data migration projects as well. Why have we shifted to the cloud? Purely because of the enterprise scalability and performance that comes with a click of the button. Truly amazing. In the old days, having a server with a couple of racks and then trying to upgrade that over time, what a nightmare. Now we just drag the slider and we have what we need. Out the box redundancy, 100% serverless. Thinking about zone redundancy and even availability zones that are offered by Azure. But let's face it, when a country goes down, there's bigger problems than just worrying about our integration still running. Think about single organizations having different requirements within them. This is a big issue at times. We're going to look at that. Pay as you go, strong incentive. Think about that picture there. You can see of the fancy car. You go and buy a fancy car, and you drive it maybe once a month. Do you want to spend all that money, or do you just want to call a cab when you're ready to take your trip? And that's pretty much what we're talking about when we go pay as you go, especially the consumption model that we love so much. As your sales increases, so your transactions increase, therefore you need more performance. It needs to increase, but so does the cost. But here's the key. When you're not making those sales, well, you're going to have less transactions. You're going to need less performance, and at the end of the day, it's going to cost you less. You're not just going to pay for something fancy sitting there doing nothing. A key point that we want to bring out is also, how can we recover these integration costs? Typically, integration costs always been bundled in with the IT expenses. But now, maybe we can get to that elusive customer admin or platform fee that we can pass on to the end customer. Just to let you know, our first production go-live project using the full Azure Logic App Service Bus functions project was done in June 2018 between Salesforce and AX 2012 R3. Customers, vendors, the full shebang. That's what we've done. All right, let's move on to that project statistics. We had a number of different connectors, obviously Salesforce, AX 2012 R3, which didn't have a standard connector in Logic Apps. So what we had to do is we had to write a REST API wrapper to wrap the SOAP services of the on-premise AX solution, and then using our custom connector to hook into that and pass the JSON to convert the XML into AX 2012. D365 FinOps, well, that's great. Comes with a standard connector, so we don't have to worry about that. A lot of other third parties, websites, other systems providing us data, other systems online, cloud systems like Zendesk, Jira, SharePoint, Office, and importantly, we'll talk a little bit later about Azure Data Lake and Data Factory, as well as this solution also had some elements of master data services, so using the SQL connectors available in Logic Apps to hook into the back end of that. Just to give you some statistics, the system that we came in to replace used to process a service contract one every 45 minutes. Now, a service contract is not just one thing. It's made up of many different components, customers, vendors, you name it. But that whole process used to take like 45 minutes. Now, we can process 55 every hour. About 40,000 of them are being processed every month. What's nice about in Azure using the dashboards, we can hook into various Logic apps that show us what our processes are doing. And we can start to get some insights into things. For example, how many contracts are we processing? And you can see the variations, the different days. You can see the spikes in integrations. Why are they processing 5,000 contracts on that day? Giving us insight, going back to business and finding out what's going on. Also kind of looking at the seasonality of leads and opportunities coming into the organization. Obviously, over the weekend, you can see less than during the week. What does all of this cost us at the end of the day? All of this work, all of this processing, crazy as it sounds, about $200 a month. And that's if they're making a lot of sales. All right, let's jump into the business patterns, business requirements and costs. Very important. The smaller the organization, the easier it is to standardize. But when you start dealing with multinationals, companies that have footprints in different countries, you start coming across the concept of having companies within companies. And then they have different requirements, different systems to integrate, and of course, a multitude of different egos. So we've got to make sure that we realize the reality that as developers, we all try and make things generic. We want to use the same thing over and over again. But one size fits all, and sometimes an integration is not reality. We just got to face the fact, and we've got to address that. So how did we go about trying to segregate, ring fence different business units and environments? Well, we used our resource group per business unit, per environment. For example, Australia, UAT, Australia production. We can now tell you what's running in Australia in production and in UAT because we've got a resource group. All the components in the resource group, ring fencing costs for that business unit in its resource group. Same logic app, yes, that we may have the same set of integrations. We deploy it into these different environments. It may all be the same from the same code base, but if there are different requirements in those areas, we can branch out and host a different version of that logic app. And then getting to that customer admin fee or platform fee that we've been trying to get to. Now that we have a resource group per business unit, per environment, we know at the end of the month how much it costs us to run Australia or North America in production. Now, if we take that divided by the number of customers, we can now start looking at an average cost that we can start passing back to the customer and recover those integration costs, not just having them all lumped into the IT budget. One thing we always say is please understand why you're going to use a resource group. Don't just view it as a folder to throw random things in. Look at your resource group and think carefully about how it's going to help you achieve your objectives. All right, let's look at decoupled integration design. So this is what we're trying to get here. We're trying to get to a place where all the different integration components run on their own. They don't know about each other. Why is this important? Well, when you have a massive system integrating multiple things, if one component goes down, we don't want the whole integration system to go down and stop. Everything's got to keep on working. And maybe one system's down. When the system comes back up again, all the messages are queued and carry on. So we've got to really try and decouple and have things running on their own. That means different components should do one and one thing only. This is where Azure Service Bus has really helped us. Really, it's helped us here because by means of a queue, we can have Azure components such as the Logic app consume information, process it, and send a message. Sits on a queue. Then you have another Logic app on the other side, grabbing that message, doing what it needs to, and pushing it off. Doing that way, the Logic app can do one thing, and yet your message is still kept in between. One thing we've come to realize, each queue that we create should only be for one type of payload. Don't have a queue with multiple payloads. It just doesn't work at the end of the day. It gets too complex. So queue, message, Logic app, read, send it. Dead letters, we enable dead letters on all our queues. Why is this great? Because if anything in the Logic app fails, we just automatically dead letter the message that we were doing. So we've got an error queue. Those messages sit waiting for us to eventually reprocess, investigate, and handle. Nothing, no instruction, no event gets lost. And that's so important in a big integrated system. Just to have a look here, for example, the system that I've been talking about, if you have a look here, in 30 days, we're talking about 1 million requests and about 230,000 messages. What's the difference between requests and messages? Well, requests are any actions on the queue message. Messages are actually when you have processed the message and it's been completed. How much does this cost us at the end of the day? As crazy as it sounds, 10 cents. Yeah, 10 cents on the consumption model. Don't forget to use message properties such as correlation ID, label, and message ID. What this is going to help you is, because now we've decoupled all our different processes through different logic apps and different messages, we want to be able to pass through an identifier to track all these different components and how they relate to each other. And that's so valuable in using these properties on the messages to track, and so you can see what is all related to each other. The disadvantage, though, of decoupling everything and having a message in between is that the logic apps have got to read the message, and those messages are based on recurrence. So the connector looks at the queue every second, every minute, every hour. So it's not really event driven. So for example, if you had a logic app that was triggered by an HTTP request, you could trigger the event immediately. Well, now we're not really doing that. So as close as being to event driven we want to. Some cases we can do that, but most cases the pattern is send a message and action the message. One thing we're going to always ask you to keep in mind is your payload size. That's what I'm talking about, is the message size. Now, it is possible in the queues to have a very big message, but remember, your logic app components such as parse, JSON, and your arrays have limitations. This hit me big time. Developed a whole process, and eventually one of the messages that came through were too big for the components to process. Had to throw that solution away and redesign it. Think carefully about your payload sizes and the limitations of components within within logic apps. Service Bus Explorer. Thank you so much, Paolo Salvatore. We've been using your desktop client for all these years, these 4 years. What a wonderful tool. But now a lot of that functionality is available in Azure Service Bus. You'll see it there when you go to your Azure Service Bus namespace. On your queues, you'll be able to peek and edit the message, resubmit the message, complete the message, delete the message. Most of that functionality is available in the browser. Okay, I told you it was going to be fast and furious, and truly is. We're looking now at some of the patterns within your logic app. And when I talk about logic app, we're talking about the consumption model. We love the consumption model. Why do we love the consumption model? Because it's 100% serverless. It's true, a single logic app can only have one business process, but that's our design. We want it to do only one thing. One of the things that have been very important to us is naming conventions. I'll tell you why. When you use the Azure search box, if you have named your logic apps consistently, you can find logic apps that relate to each other and process that relate to each other by simply just typing in the words. So our convention is, we say business process, source system to target system. So in the case of like this one here, sales order, Salesforce to ASB, Azure Service Bus. Then on the other side of the coin, sales order, Azure Service Bus to D365 FinOps. Easy to understand, easy to find. Some key things you need to please remember when you're designing your logic apps are these two things: the retry policy on some of the connectors. Now, by default, it is the default setting means that it will try 4 times to action if there's a problem. Now, our design policy is always to set it to none. always to set it to none. And then when we have to, change the retry policy to a policy that is going to be resolving an issue. Now, why is this important? Because that we've set it to none. We see when our logic apps fail on bad gateways and timeouts. Yes, we may need to add ways to overcome it, but at least we are notified. At least we understand what's going on. At least we see what we need to fix. Another thing that's important to remember in your logic apps is the loop concurrency control. Now, by default, this loops will run in parallel 20 things by default. This is not a bug, as some frustratingly have asked. It's a powerful feature if you know how to use it. But once again, our design policy is that by default, when we come to these loops, especially on the parent, we will always set the concurrency control to 1. And then when we need to, and we understand why, we will increase it to the level of parallelism that we need. One thing to keep in mind, please, always, is that each action in a logic app costs you something. So try as you can to consolidate logic and processing. For example, when using GET requests to look up data in a system, yes, you can maybe do like 5 GET requests to look up the customer, look up the contact number, look up the address, look up, you get what I'm saying. But some of the components, like for example, Salesforce has a component called execute SQL query, where you can actually create this complex query like with joins in it. And then instead of doing all those lookups, you just do the one action. So you can imagine you do one action versus 5. And you talk about 40,000 contracts. You can imagine the savings that you get on that and on the processing time. Also, keep in mind that your logic apps only allow a nesting depth of 8. Don't get to the point like it happened to me, where you've developed your whole logic app and it's running, and then you realize you need to add some more logic in, and you try add your next layer and you can't, and then you have to rework that whole thing again. So once again, design before developing. Okay, moving on to error handling. 2 types of errors. We like to classify them. One is a handled error and one is an unhandled error. Handled errors is we know what's going on. We know why it fails, because the email address is not valid, correct? Or there's some processing logic. Whatever the case may be, we always store the errors, the results. We never just delete them. We always keep them. We always try to understand them. And then in most cases, we always broadcast those failures, whether broadcasting those failures via email to the support team or to the user, we inform, we communicate. Unhandled errors, things like API rate limits, gateways unavailable. Wow, I can't believe sometimes how many times the gateways are not available. Bad gateway. Maybe you've got some bad code. And for example, like the parse JSON, maybe the payload doesn't adhere to the schema, so it'll fail. All these kind of unhandled errors we catch and we generate. And then what we do is we send like I said, we send a message off to the relevant party. Now, I just wanted to show you the kind of an email that we send. Put the logic name in the subject, whether it's successful, failed, even put a little bit of the message of what failed. In this case, the duplicate value was found, and then using the logic app run ID as a hyperlink in your messages. So valuable. For one click, it can take you to the instance of that logic app and you can see where the failure was. Once again, keep in mind, keep the message until you know the message has been fully actioned. Whether you have to resubmit it manually or have a process that automatically resubmits, it doesn't matter. Keep it. Don't delete anything until you know that you've done what you need to do. Just to show you how we handle unhandled errors here, the try-catch best practice method in all coding. We know how that works. How do we do this? How we implement in Logic App? Simply by using a scope component. That scope component says anything that happens in that scope component can be successful or can fail. And then what we do is once we've got that, then we will use a filter on the result of the scope and get out the actual error. And once we've got the payload errors out of that scope component, you can then process it. In this case, what we do is then we send that error to a generic logic app, which knows how to decompile or process that JSON and then send on the relevant errors and messages to people and systems. Okay, advanced transformations. How do we handle this? Well, by using two tools available to us, Azure Functions and Azure Data Factory. Azure Functions are wonderful. It's wonderful to have this piece of C# code just floating out there in the universe and being able to be called. Really, it's incredible. But think about things like complex XML or custom EDR, electronic data exchange contracts. You'd be amazed when you deal with integration how many different formats are out there. Even some integrations having like hidden characters as delimiters. Now, when you've got C# in your toolbar, you can just code anything. You can do anything. You can create, consume any contract. We love using the C# classes, using data annotations and validations to help us actually validate the payloads that we are passing in. Of course, hooking it into Azure DevOps for version control, and then even being able to do automated unit tests on that. It's true, you can use other tools like liquid templates. But in the case of us, in the consumption model, we realized that those things come at an additional cost. And once again, you're having to provision resources that sit and wait there for you to use them, where we're trying to do everything pay as you go. So for example, you're going to have to, if you want to use liquid templates, you're going to have to upgrade your logic app pricing tier. And you're going to have to get an integration account, which is essentially gives you access to an Azure blob storage where you keep your contracts and schemas and all of that kind of thing. There is another tool that's been in preview since April 2023, last month, which is the new Azure Data Logic Apps Data Mapper. So check that out. Unfortunately, it's not yet available for the consumption model, but we'll keep our eye on that and see what we can use that for in the future. I just wanted to show you an example in an Azure function here and how we're using the Azure function here. So here we've got a class, obviously got the different attributes of the payload, but you can see what we're doing. We're using the annotations. So we're saying this is a required field. And if it's not required, and if it's not provided, then send back the error message here. Submission method is required. And then what we have is we've got our methods where we actually go and then generate. In this case, it was a very customized version of an XML document. We had to customize it and put in the various placeholders there. So love using Azure Functions for doing some more complex transformations. Talking about Azure Data Factory for advanced transformations. You must say, why do we need Azure Data Factory now with Logic Apps? Well, let's face the facts. Logic Apps are not designed to manage bulk data. It's a process, it's a message, it's an event that the Logic App needs to grab and do something with. So we will rather offload any bulk data transformations into tools that are designed for that. And this is where we use Azure Data Factory. For example, two scenarios, just want to touch base briefly with you. Scenario one, we need to get a whole lot of data into Azure D365 FinOps. So what do we do? In FinOps, we go and we can generate what we call a package, which is like it's a file schema that tells you how to structure your data and store your data so that it can be imported. So what we do now is we have an Azure pipeline that gets the data, transforms it, and zips it into the correct format, uploads it onto Azure blob storage. Build a Logic app that monitors that, grabs the file using the connector, standard connector, upload the file into FinOps, and then FinOps does all the bulk loading, importing, not having the Logic app having to loop through each and every single record. Scenario two, looking at where users upload their templates, their documents into a SharePoint location, having a Logic app looking at that SharePoint location, grabbing the files, and then sending that file onto an Azure Data Factory pipeline, letting it do its work, and that maybe even writing back to the underlying databases. Just want to show you a quick example of this here. So here we've got, you can see here we've got an Azure Data factory pipeline. It's reading some files, it's doing some conversions, we pass in some parameters, then we merge some of the files, and then we actually write the files out to a database, the results of it to another database, and then do some cleanups. And then here in the Logic app, we use the Azure Data Factory Pipeline connector, connecting to our environment, and then just passing through via parameters reference to where we're storing the file on blob location for the Azure Data Factory Pipeline to pick up. Okay, last but not least, we're talking about the patterns for building, testing, and releasing. So this is where we love Azure DevOps, because Azure DevOps allows us to connect into our different Azure environments. And we can code on our laptops, we can code in the browser, we can code wherever we are, we can have it importing, exporting, but our code is all going to be in a repository. That repository is going to be built. It can test the results of the build. And then when we're ready, we can deploy that information, those artifacts, into our different environments. So for example, here we've got our build, and then we push it into our test environment. At the same time, we push it into our UAT environment. When the UAT environment is done, we get an authorization that pushes it through into prod. Sure, you're familiar with these kind of approaches already. But what we do is the way that we define these ARM templates is important for us. We've come to understand and appreciate that each Logic app should be in its own template. And then the rest of the resource group, like the API connectors, service bus definitions, or the storage locations, we can group that into a template. So if I just zoom in here, for example, we'll have a resource group. And in that resource group, we'll have a whole lot of different things like our service plan, function app, all of that managed by this deployment in the resource group. Typically, that doesn't change often. But each Logic app here, each Logic app will be on its own. And then in the deploy release, we will obviously deploy our resource group and our different templates. And what we will do is deploy and release each Logic app individually. Why is this important? Because if the Logic app fails, we know the Logic app failed. We don't have this massive script with 20 Logic apps that fail. Now, which one, and try to find in that script. We handle each one individually. This helps us when we do automated builds and testing, being able to pass the sample payloads to test these Logic apps. And also we can generate pull requests when we work on a specific Logic app for a teammate to action and to update. And then obviously just that piece of code is going to be affected and changed, not a whole massive big deployment script. Those are some of the patterns and concepts that we wanted to share with you today. It was fast, it was furious, and we hope that one or two points have stood out to you, and we look forward to hearing more from you and answering some of your questions. Thanks so much.